they use plywood, right? But with plywood, you come with the timber, come with the nail, and you know, later on, after you use 3, 4, 5 times, you have to, you know, put it in one rubbish bin and discharge. So the wastage is very high, right? But using our Lego system, right? The interlocking is using the U-claims, and you can make the panel. You don't need the timber, you don't need the nail. So with this, it's easier to construct. With the ease of construction, you can do it faster. Of course, with all these things, again, similar to the post-tensioning, you have a more economical. Because this panel is a fiberglass together with plastic, right? You probably can use it 80 times, 90 times, 100 times. So it becomes cheaper than plywood if you compare the cost. Wastages is almost zero, right? And because of this, you don't have any nail. Like usually for construction, one of the safety things is you have nails on the timber, just on the floor. So with this one, you have very clean construction site. If you want to save the trees, you want to save the earth, this is one way to do that, because it's a recycled product, using the fiberglass and the PVC. The next one is precast element. So far we have been post-sanctioning, formwork is all in situ, right? So another way of another technology is using the precast system. Okay, we have the hollow core slab and also for the wall. That's the plant. This is in Malaysia, because for this precast element from Malaysia to Singapore is only about 20 minutes. Yeah, so we have to take care of the logistic as well for precast element. Logistic is very important aspect. Okay, for the precast wall, if you use normal bricks and mortar, right, you need the plastering, you need all these skilled workers, right? For this one, is much faster. So it's a faster construction. But the only disadvantage slightly is the pricing. Usually it's not more economical than the brick and mortar. It's more expensive. But in Singapore, they do not allow using bricks because they want higher productivity. So in Singapore, we have no choice but to use precast wall. They will not allow to use any other method. Okay, this is a newspaper cutting. It's just on the 4th of December, just 2 weeks ago, right? You can see how technology is being used in the construction industry, right? Especially for precast element, we use every precast element are tagged RFID. So basically, what for the 3D modeling, we know exactly which element, when to put, where to put, so it will not have any mistake. For precasting, is the precast management of the precast elements is very important. So using technology like RFID, using the BIM, 3D modeling, all these things, with the camera, with the crane. So we have developed a system to make the precast easier. So again, this is one example of using technology. The next one is on the modular construction. What we are trying to do is in Singapore again, we had near the airport, Singapore airport, there's a Crown Plaza Hotel. There were 200 rooms. These 200 rooms was built using a modular construction. So every room was completely furnished, completely done in Shanghai. Then from Shanghai, we ship it to Singapore. Then we just stack up one on top of the other. Okay, these 200 rooms was installed within 1 month. Then the handover was done within another month. So 200 rooms was basically done within 2 months. A 200 rooms hotel within 2 months. Yeah. So especially for the hotel operator, they are very happy, right? Because the moment earlier the hotel is ready, the money will come in earlier. So even the construction cost was higher, but end of the day, because of the time saving and the revenue from the rooms, it was better for them to use modular construction. So that's another area of technology that is something that we can explore. Okay, the last one is this technology is started in Austria, right? About 20 years ago, by a company called Bubble Deck. Right now they have a few other companies doing it. Okay, the idea is this: where, because concrete is good in compression, it's similar to hollow core slab, right? So where you don't need the concrete, we put the bubble, the plastic bubble. Okay, so this is not new. The thing that is new is what we did is we combined the bubble deck technology together with a post tension. We marry them together. Okay. For bubble deck, just the bubble deck itself can cut down the concrete weight by about 30%. Right. So if you have, say, a building that is 1,000 meter cube of concrete, for example, you can save 300 meter cube, right? But with post tensioning added in, we managed to cut down the weight or the volume of concrete needed by 50%. So if you are talking about a building of 1,000 meter cube of concrete, you only need 500 meter cube now, right? But the main saving is on the foundation, because if you have your building weight, total building weight is cut down by 50%, your foundation saving will be there. Okay, so that's about all the development in technology that we have ventured in. We are still looking for new things, and hopefully with the Alexandria University, and we can carry out more R&D and probably develop other things that can be of interest for Egypt and the world. Okay, shukran.
Any question? Can you ask? Dr. Rabia. Okay, go on.
Yes, my question to you, thank you, Dennis. My question to you is about the first part of your presentation, the post-tension. What new development you have in this system different from other companies or other systems?
Okay, the new development we are looking at is because post-tensioning so far, is mainly for the concrete structure, right? We have done in China a full-scale test for a friend of mine using post-tensioning in the steel structure. Yeah. We are in talk with the university in order to develop because you have the software part, which is the empirical part of the design.
Yeah.
What we have done is so far a full-scale test on the actual. Okay. We find out that say for example the I-beam. Okay. For the same load, let's say the I-beam say is 1 meter depth I-beam. We cut down the I-beam by 500 and we use external force tension unbonded at the two sides with the web. We can achieve the same load. Right. So this is something that we are looking at now because so far most of it we are talking about concrete, but not on the steel. So that's a new field that we are looking at.
Thank you.
Go on. Ask him. Dr. Ashraf,
Yeah.
you don't have any question?
No, I don't.
Gentlemen,
No, thank you.
no other question? Just leave him without question.
I think all
You
of
are
you must be
satisfied,
very
you are
tired.
satisfied with the lecture? You, Ismail? You
So,
like the
okay,
lecture?
just
Anyone? Any engineer, you like the lecture? I like. Very good.
okay, maybe just to close it, since most of you, okay, my dream, being an engineer, okay, is always to encourage, you see like doctors, lawyers, especially in the IT, right? They are constantly developing themselves, okay? And they have a certain pride in doing so, okay? So this is a very good thing, especially for the university, for the So we should make us as engineers proud. I mean, we are already, when we see the building, we see the bridge, we feel, but if we can adopt, we can continuing evolving and trying new things, right? It's something that hopefully the university or all of us here can put in the new generation engineer so that they can feel something, to look at. Right? Because you see, concrete 100 years ago and concrete now is still concrete. Right? But we have developed into lightweight concrete. We have developed steel structure. So I just hope that with just little bit that we have done, more can be done. Yeah. So I just encourage all of you to to embrace the technology. Thank you.
Thank you.
Who's the next? Sika? Who's the next? مين يا احمد؟ سيكا. مش حد تاني عندكم؟ سيكا. تاني؟